Welcome back to Edulexis. Today is day 52 of our complete Python programming course. In past videos, you've used for loops everywhere to look through lists, strings, and dictionaries. But have you ever wondered how Python actually fetches items behind the scenes? Today, we are demystifying iterables and iterators. By the end of this 15-minute session, you will know exactly how Python's loops work under the hood and how to build your own custom iterator objects. Let's dive right in. Action: show a clean title slide with day 52, Iterators and Iterables. To understand this clearly, let's use a simple real-world analogy. Imagine a bookshelf. The entire bookshelf filled with books is like an iterable. It's a collection of items you can look through. Now, imagine a bookmark or a person walking down the shelf picking up one book at a time, remembering where they left off. That bookmark or person is an iterator. An iterable holds the data, while an iterator is the stateful helper that fetches the items one by one in order. Action: display a simple graphic animation on screen contrasting a bookshelf and a bookmark. Let's look at code. What exactly makes something an iterable in Python? Any object capable of returning its members one at a time is an iterable. Common examples you already know include lists, tuples, strings, dictionaries, and sets. Technically speaking, an object is iterable if Python can call the iter function on it. Let's open up our code editor and test this concept out with a basic string and list. Action: switch to IDE, create a new file named day52_demo.py. Let's write a few lines of code to check iterability. Type my_list equals 10, 20, 30. Now, how do we know if my_list is an iterable? We can pass it into the built-in dir function or check for the presence of the _iter_magic method. Let's run a quick check using has@tr my_list_iter_. When we execute this, Python returns true. Every standard collection in Python has this magical __iter__ method built right into it. Action: type and run the snippet in the terminal, highlighting the true output. Now, what happens when we take an iterable and call iter on it? Let's do that right now. Type my_iter equals iter my_list. Notice that my_list itself is not an iterator. It doesn't have a __next__ a method. But my_iter is. An iterator is an object that represents a stream of data. It remembers its current state and knows how to fetch the very next item using the __next__ function. Action: print the type of my_list versus my_iter in the terminal. Let's see the iterator in action. We call the built-in next function on our iterator variable, print next my_iter. What output do we get? 10, the first item in our list. Let's call it again, print next my_iter. This time we get 20. And a third time gives us 30. The iterator keeps its internal state, advancing forward step by step with every single call. Action: execute these next calls line by line, showing the progressive outputs on screen. What happens if we call next a fourth time when all items have already been fetched? Let's try it out, print next my_iter. Python immediately raises a stop iteration exception. This is not a crash or a bug. It is Python's standard way of signaling to loops and callers that there are no more items left in the stream. Remember this exception name, as it's crucial when building custom iterators. Action: show the traceback on screen pointing specifically to stop iteration. Now comes the big revelation. Whenever you write a standard for loop in Python, like for item in my_list, Python is actually doing all of this behind the scenes automatically. Python first calls iter my_list to get an iterator, and then repeatedly calls next inside an invisible while loop, catching the stop iteration exception quietly to know exactly when to terminate the loop. Action: show a diagrammatic flowchart mapping a for loop to underlying iter and next calls. Let's write code to prove this loop mechanics theory. Let's manually simulate a for loop using a while loop, iter and next. We write nums equals 1, 2, 3, it equals iter nums, while true, try, val equals next, it, print, val, except stop iteration, break. When we run this, it prints each number identically to a normal for loop. Action, type and run the manual loop simulation in the IDE. Now let's level up. Can we create our own custom iterator from scratch using classes? Absolutely! To make a custom iterator, a class must implement two special magic methods, __, iter __, and __, next __. Let's design a simple countdown iterator class called countdown that counts down from a given start number to 0. Action, start typing out the countdown class skeleton in the editor. Let's write out the first two methods of our class countdown, def __init self, start self.current equals start def __iter self return self. Notice that __iter simply return self. This means our iterator object is also an iterable itself, which is a very common pattern in Python. Action, highlight the code blocks as they are typed in the editor. Next, let's write the core __next __, a method that controls the counting logic, def __next self if self. Current less than or equals 0, raise stop iteration else, num equals self.current equals 1 return num. Look at how clean that is. If current hits 0, it raises stop iteration, otherwise, it decrements and returns the current number. Action, carefully explain each line of the next method implementation. Let's test our custom countdown class in action. We instantiate it with counter equals countdown 3. Now, let's run a for loop directly on our custom object, for num in counter, print num. When we run this script, the console prints 3, then 2, then 1, and then terminates cleanly without errors. Our custom iterator works perfectly with Python's native loops. Action, run the complete script and show the successful console output. Why go through the trouble of using iterators instead of just returning a giant list? Memory efficiency. Iterators are lazy evaluators. They generate items on the fly only when next is called, rather than storing millions of items in RAM all at once. If you are processing massive datasets, log files, or infinite streams, iterators are an absolute game changer for performance. Action, display a comparative slide showing the list, eager loading, vs iterator, lazy evaluation, . That brings us to the end of day 52. Let's quickly recap. Iterables hold data and provide an iter method, while iterators remember state and yield items using next until stop iteration is raised. You also built your very own custom iterator class from scratch. If you found this video helpful, smash that like button, subscribe to Edulexis, and turn on notifications. Tomorrow on day 53, we'll take this a step further and learn about generator functions and the yield keyword. Keep practicing, and happy coding. Action, show outro screen with Edulexis branding, playlist link, and subscribe button.
Thank you for watching. Like if you learned something, share with your circle, and subscribe for more.